Let me show you how to calculate the velocities, the expected velocities on an energy ride. And these are theoretical. These are, of course, if there is no friction. Okay, so let's imagine that we've got this energy ride. Here's the ground here, and we start off here, and we go here, and here, and here, and we've got all these different heights, right? There's always this initial height, and I'm guessing that we probably don't have a lot of kinetic energy at this point. And so we've got this car like this, right? Here, we'll just draw that there. Okay, and it has some mass. And right here it's got mgh. And then when we see it later at some other height, it's got a different mgh, right? So let's say that this height is 31 meters, right? And then let's say that here we're at 20 meters. And then here we are at 18 meters. And then here we are at maybe 10 meters. Right? What we can do is we can say, okay, this initial potential energy here is going to equal mgh equals this other height plus 1/2 mv squared. So we're just going to say that the velocity is 0, right? Even though it's really not, okay? And so what you do then is you just cancel the mass, because of course we don't know the mass. Now we could make something up, but we don't have to, right? And now we're set. Now we can go 9.81 times 31 equals 9.81 times 20 plus 1/2 v squared. Then we can solve for the v, right? Let's see if we can do this. I think I can do this. All right, so this is going to be the square root of 2 times 9.81 times 11. All right, square root of 2 times 9.81 times 11. I did a few steps there. And that means it should be going 14.7 meters per second here. No, that's pretty fast, right? Okay. And the reason I can do that is that basically we just descended 11 meters, right? And so it's the square root of 2gh in general, right? And then here I could do the same thing, right? So my mgh at this point, right? This initial mgh, right, is equal to whatever this mgh is plus 1/2 mv squared, right? Then I can plug in, I can cancel the m's again. We can go 9.81 times, we started at 31, right, is equal to 9.81. Because you can always compare this spot here to any of these spots, right? Times 18 plus 1/2 v squared. Okay, so let's see. 9.81 times 31 minus 9.81 times 18 is that times 2 raised to the 0.5 is 15.97. That's how fast it'd be going here, right? Let's double check that. Let's see. What's our change in height? I feel like it's 13. Is that right? 13 plus 18 is 20. Let's check that. 13 plus 18 is 31. All right. So square root of 2 times 9.81 times 13. Yeah, that works, right? And you can do exactly the same thing here, right? We can set up a mgh. And this mgh, right, is equal to this mgh plus 1/2 mv squared. Okay, so we'll just make a little tacit assumption that the initial velocity is just not very much. Okay, certainly in the case of the big pink slide, it's not much. In the case of adrenaline peak, you're not going that fast. So we'll just say that velocity is 0. All right, hope that helps.